How can I change my design as fast as I change my mind? With synchronous technology, design reuse doesn't have to mean remodeling. Anyone can change any model regardless of who created the original without having to unravel and debug how it was built. The result? Engineering change orders in seconds that would have taken hours. In this gas turbine assembly, we have been asked to make a number of changes to the main shaft. In conventional history-based models, this would require an understanding of the construction approach. Synchronous technology removes the need to understand the way a part was designed. Simply selecting what needs to change and to change it, rotating with simple pick and drag options, making model changes fast and visual. More control over the behavior of the model can be achieved by adding 3D dimensions. Real-time dynamic feedback ensures that we get exactly the change we want while making sure that all the necessary geometry is updating, reducing the time taken to perform the modifications. Many times, more than one component may need changing to ensure design compatibility. Using conventional approaches, we would need to open each component to make modifications. Synchronous technology allows us to make changes in related parts, speeding the design change process. Let's look at a more complex geometric case. Take this complex part with over 1,500 features in a traditional history tree. When an engineer wants to make a change to these 3 ribs, they have to trace how they were created in the original model. After investigating the model, our engineer sees that this feature was generated by sketching a profile. This was done very early in the model development and appears early in the history tree. Selecting the profile allows us to edit the dimensions using the same constraints as originally defined at creation time, but these constraints complicate the edit we now need. The original designer may have had some ideas on what was a likely change, but how could they have predicted that we would want to make this change? To make this simple change, the user has to understand the way the model was constrained. Once they do so, the history is replayed to get the model to update. Notice how long it takes for the model to recompute. With synchronous technology, a user simply selects the geometry they want to edit. The powerful feature recognition understands the functional form of the ribs and selects everything we need by using the geometric recognition capabilities, reducing the need for the user to understand the modeling process. This leaves the engineer in total control over what changes within their design. Let's take a close look at a new technique we call procedural features using a pattern. Notice how a dimension can be used to change either the overall shape or the size of the pattern. Notice while the pattern was created last, it can drive the initial base shape, a first for CAD. A pattern's instance can also be edited. Watch as the entire pattern maintains the requested size. Patterns are procedural features and support parameterized edits, such as instances, but allow direct modification. These features are unique in the industry. Only with synchronous technology will users have this level of flexibility.